All right. Well, welcome back, everybody. And welcome, Tim. Thanks for the congratulations. Um, we're gonna kind of hop back on this. I do want to tweet that we're getting started, just in case people have forgotten. It's quite a busy day. Um, for me, anyway. I just finished watching the inauguration, which ended like 30 minutes ago, and so of course I'm running slightly behind on everything. But let me go ahead and tweet about this really quick, just so folks know. I should also tweet the link. Excuse me. Tweet the link here. So I'm going to share this. Yeah, it's the video link. Apologies, I should have done this before I got started, but that is just how things go sometimes. Okay, I know a lot of folks have other things on their mind, so that's what the recording is for. And maybe I'll say something on Facebook as well. Okay. Okay, great. And let me close that stuff. All right, well, welcome back, everybody. Last time we made a whole lot of progress. These first few days really are focused on getting the basics of Python syntax, because once we have the basics of our syntax, we can start to build scripts that we will use to do all sorts of interesting analyses. So why don't I go ahead and share my desktop here, and let's dive right into it. Now, just as a reminder, I have a folder on my desktop called From 0 to N, and inside this folder are the scripts that I've been writing for this workshop. So last time we talked about strings, we talked about how to count substrings, we talked about how to divide strings into different parts and add them together and do a little bit of math with them. We talked about mathematical operators, so addition, subtraction, multiplication, integer division, modulos, and exponents, right? We talked a little bit about Booleans, and then we finished up talking about lists. Or actually, we talked about lists and then Booleans, I think. But either way, all of this is up on GitHub now, so you can go and look at the code to remind yourself of what we covered. And today we're going to introduce slightly more complex structures that will let us, build some analysis programs. I'm not sure how far we'll get today, but I think we might be able to get to writing our own functions and possibly into NLTK, the Natural Language Toolkit. And that's when we're really going to dig into doing real analysis. And we're going to talk about going from a string, which is what we've been talking about these last few days, to units that we can actually analyze. And how do we break apart language into atomic items that we can count and analyze in some manner or another. So I'm really excited about that. And we will talk about the differences between English. We'll talk about Chinese. We'll talk a little bit about French. That might actually end up coming tomorrow. But I do have 3 folders here on my desktop. Let me zoom in here. I have this nice zoom setup so you can get a little bit better of a sense of what I'm looking at. Let me make this a little bit bigger. Okay. So I have 3 directories here. I have an English, a Chinese, and a French directory. And inside these folders, I have files, which of course is probably not a big surprise. But I got these from Project Gutenberg. And I have, for English, I just grabbed The Adventures of Sherlock Holmes, The Memoirs of Sherlock Holmes, and The Return of Sherlock Holmes. These are 3 short story collections written by Arthur Conan Doyle. They are in the public domain, and so we can do our analysis on them. I used to use the Federalist Papers for a lot of these sorts of demonstrations, but that's perhaps less interesting for people out there who are not from the US. And of course, Sherlock Holmes is perhaps also pretty Anglo-centric, but it is perhaps a little bit more of universal interest than the Federalist Papers are. So we're going to get in probably tomorrow into opening these files up, dividing them up, cleaning them, and then running some analysis on them. But we'll also be taking a look at the nuances of working with different languages. So in my Chinese directory, I actually have 3 texts. These are the Sanyan texts, the 3, I don't know how you would translate that, the 3, anyway, there's the Jingshi Tongyan, the Xingshi Hengyan, and the Yushi Mingyan. So these are all short story collections that were compiled by Feng Menglong in the 17th century. And we're going to use these as examples. Now, perhaps these aren't the best examples because these are written in classical Chinese rather than modern Chinese, and the natural language processing tools we have don't really work very well for classical Chinese right now. But I'll show you how to do it as if it were written in modern Chinese. And then finally, for French, because I am not super familiar with good French short story collections, which I thought would be nice for a little bit of parallelism, I just grabbed Du Côte de Chez Swann. And apologies, my French is awful. I can read it okay, but I can't really pronounce it very well. This is Swann's Way by Proust. And so we'll divide this one into chapters, and we'll kind of walk through the process of, doing a little bit of analysis. So I think this will be really fun. Hopefully today we will get to the point where we'll be ready to do that tomorrow. And as a heads up, on Friday, I have to be out of town for a doctor's appointment, but I hope to still stream, but I might not be streaming on my nice computer. I might have to be using my laptop. But that's just a heads up, and we'll kind of see where we are at that point. I think we'll have a lot of interesting things done by then anyway. So we'll kind of see how this goes. All right. So let me close this, and I'm going to back out to my non-zoomed desktop here, just where you can see the whole thing here. And we're going to take a look at from 0 to n folder. Now, one thing I should say is over on GitHub, let me open this up. On GitHub, I did go ahead and upload these 3 folders of materials. So we have the Feng Menglong Sanyan, 3 sayings, or 3 yen is like language, but it can also mean it's related to literature, and they're short story collections. Anyway, apparently it's too big to actually view, but that's not actually that big of a deal. And we have the English here, Adventures of Sherlock Holmes, and the French. Now, what you can see, though, is I actually left this in a state that would reflect what it would look like if you just went off and downloaded these texts straight from Project Gutenberg yourself. So I did go ahead and I left in the preamble, because we will talk about how to remove this preamble in the process of doing our research. And we'll talk about dividing these texts, and we'll talk about some of the issues you run into when you do something like this, because you might think, when I try to divide this text into different parts with my code, I can look for certain patterns. So I can, for example, look for Roman numerals, and we can see that, for example, each short story seems to start with an I and a period and nothing else on the line. A Roman numeral and a period and nothing else on the line. And so we might write a regular expression, which we will talk about, to divide this up. But I think, because I have taught with this before, at least one of the Roman numerals doesn't have the period. So we need to make sure that we're aware of that as we work with it. But we'll come back to that as we talk about slightly more advanced things. We're not quite ready for that. We still need to talk about a few constructs in Python syntax that will get us to where we need to be. So I'll go ahead and I will minimize this because we might need to take a look at that later. And what I'm going to do now is I am going to just open up my plain text editor, And we can see that I was still working on bool fun from last time. I'm going to go ahead and close these. Ooh, I didn't save these. That's fine. So I'll save that, string fun, basic Python. And now I'm going to start a new file here. And in this file, we are going to start talking about loops. So one of the really nice things about knowing how to program is that it will let you do the same action again and again and again and again without having to write it out very extensively. And I'll show you what I mean by this. So I'm going to save this as loop fun.py. You can see I'm very skillful at naming things. And I'm not very creative, unfortunately. But the key thing here is that loops allow us to execute code again and again. And this is what's going to let us build relatively powerful scripts, even with just not a whole lot of programming background. Excuse me. And in Python, there are a couple of different kinds of loops that we are going to be using. There are really two main types that we're going to encounter, and the first is going to be what's known as a while loop. So this will execute as long as some statement is true. Okay? So this is why I talked about Boolean values before we got into loops, because you have to have a good sense for how those work before you can use while loops. And so I'll give you an example of one of the most basic kinds of loops. So I'll show you why this is useful first. So let's imagine I want to just print out the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I could do something like print 1, or let's start at 0, print, and you can already see why this is a hassle. Print 2, and so on and so forth. And let's just go up to 5, 3, 4, 5. I'll save that, and then I'll run this. And you'll see that, of course, this prints 1, 2, 3, 4, 5. That's relatively simple, but this is not how we would want to do it, particularly as the number of times we want to do this action goes up. So I'm opening up my Anaconda prompt. I'm changing my directory to my desktop, and I am changing it to the from 0 to n folder. And again, if we take a look at what's inside of this, we can see basic Python, bool fun, list fun, loop fun, math fun, string fun, and of course, what we are working on right now is this loop fun file. I'll clear this with CLS. That's clear on a Mac, CLEAR. Yeah, so when I run this, so Python loop fun.py, you can see that, okay, it prints off 0, 1, 2, 3, 4. But I have a lot of code duplication here. And I can do precisely the same thing with a loop without needing to do nearly as much work. So the key thing to remember with a while loop is you write it with the while keyword, and then you have some sort of Boolean statement here. And then anything that is indented after this will run as long as this statement is true. Okay? So if I say while true, this is a statement that will run until my computer dies, or until I run out of electricity, or it runs out of RAM, or I just get impatient and I tell it to stop myself. So if I want to print the numbers 0 to 5 to my terminal, I can do something like this. I'm going to start with a variable, and I'm going to call it I equals 0. And it's conventional in Python to use I to stand in for a variable that you're going to be using to keep track of an index or to do some basic counting. And often people will then use, this is followed often by j, k, and usually you don't get beyond k. In fact, you usually don't get beyond j. So what I'm going to say is while I is less than, let's say, 6. So I want to print the numbers from 0 to 6. What I'll do is I will print I, and then I need to say I equals I plus 1. Okay? And what this is essentially doing is that the first thing it does is it will check what is the value of I. We start at I equals 0. Well, I equals 0 is definitely less than 6, so we execute the code that is indented. So I'll print I, and then what I'll do is I'll say I plus 1 equals I. So this says 0 plus 1, well, that's 1, and then it will reset the value of the variable I to 1, and then it will go back here to this while line and check, is I less than 6? 1 is, of course, less than 6, so it'll print 1, and then it'll say 1 plus 1 is 2, and then it'll say 2 is less than 6, and it'll keep going until it gets to 6, right? But keep in mind, it'll say 5 plus 1 equals 6, and then it'll say 6 less than 6. That is no longer true, and so it will exit, and it will then go on to run any code you have that is not indented after that. So if I run this, it will do the exact same thing I had before, except now if I want to instead say, as long as I is less than 10, this will print the numbers 0 to 9. So now it's very, very simple to run this code more often, okay? And this is really the utility of working with loops. And they are going to be really a lifesaver in terms of your time. But there are a few things that you need to be a little bit careful of. One thing to be aware of is, let's imagine that I forgot this I equals I plus 1 statement. So I'm just going to comment this out. If I run this, it's just going to keep printing 0 essentially forever, right? It will never hit a situation where I is not less than 6. So this will continue to run forever until I tell it to stop running. And I can do so by using Control-C, and it does a keyboard interrupt, and the program stops running. Now, if you've ever played any video games, oftentimes the main code in a video game gets executed in a while loop, because these are loops that you want to keep running until the user says, hey, I'm done playing, we can exit out of the game. So this is something you need to be a little bit careful of. There's also another shorthand we can do here. There's something we can do to make this slightly more elegant. We can, instead of saying I equals I plus 1, we can actually say I plus or equal 1. This looks a little bit strange, but it's just because this process of adding something to an integer, it's so common that we want a shorthand for it. It is also worth noting that I minus equal 1 or I times equal 1 also work. Okay, so if I did I minus equal 1, this will actually be an infinite loop as well, because it will always be below 6. But instead, it's just going to print out a bunch of numbers as fast as my terminal can print them, right? So, and this will run basically until I hit an integer overflow, which is when the computer can no longer contain that integer in memory. And there is a specific number, and off the top of my head, I'm not sure what it is, but it's a big number, but it's not an unimaginably large number. So I'm just going to stop this, and I'm going to change this to plus or equal 1. Okay, so this is a pretty basic while loop that will come in handy quite often. One thing we can also do is we can actually make this print statement a little fancier. So something I have not talked about yet, but is a new thing in Python as of, I think, 3.6 or 3.63. I don't remember precisely when it was introduced, but Python has something that are known as f strings. If I put an f in front of a string, it becomes what is known as a formatting string. And I can actually use a formatting string to directly insert the value of variables into a string. So let's say I want to say I is less than 10, right? Because this will run as long as I is less than 10. But of course, if I do this, it's just going to print out the literal string I is less than 10. So I'll run this, and you can see it just says I is less than 10 times. Sure, that's fair, but maybe I want to know what the actual value of I is. In order to do that, what I can do is I will use curly brackets to go around the variable. And so this is telling Python, whatever is in between these curly brackets, take its value, that variable's value, and insert it into this string. And so now it just says 0 is less than 10, 1 is less than 10, 2 is less than 10, and so on. Okay? There are other ways we can get the same effect that are a little bit less elegant. So instead of using an f string, we could simply say print I, comma, is less than 10. So the print statement will actually take multiple parameters. So it'll take I, comma, something else, and it'll keep going. We can actually add as many as we like. So comma, 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 and so on and so forth. And it'll just put a space in between the things you are trying to print. So if I run this visually, it does exactly the same thing. It's just perhaps slightly less satisfying. At least to me, it's slightly less satisfying. I could also do print I plus space is less than 10. So all of these are functionally equivalent. In this particular case, it doesn't like that I'm adding an integer and a string. So here I have to coerce my string or my integer into a string and add it like that. And so now it does exactly the same thing. Okay, so this is hopefully a useful thing to know how to do. I'm going to comment this out, and I'm going to leave this as our f string, just like this, because this is kind of the more elegant way of taking care of it. So this is one kind of loop. But like I said, because there is always a danger of infinite loops with while loops, in some cases you'll want to avoid them, because there's nothing, there aren't many things that are as frustrating as having code that needs to execute for a really long time and then not really being sure if somewhere inside of your code you have gotten stuck in one of these infinite loops. And there are ways to mitigate that chance using another kind of loop. You can't completely eliminate them, but it is perhaps slightly less dangerous. We can also do something like this. We can use a for loop. Now, for loops essentially take any item that is what is known as an iterable in Python. So an iterable is any object that Python knows how to chunk up into discrete units and give back to you. Okay, so a string is technically iterable because you can go one character at a time through that string, and Python will always know how to do it. A list is also an iterable because it has individual distinct items in the list. So you can say, for every item in this list, let me do something with it. So I can have a for loop, which goes, a for loop iterates through an iterable. Now I realize this is a little bit, it reads a little bit teleologically, but these are the terms that are used. So let's imagine I have a list, and I'll call this int list, and this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. What I can do is I can say for I in int list print I. Okay? And the output of this is going to look exactly the same as the output of this. Okay? Except, of course, down here, well, why don't I say, here I'll say I, let's say I is in int list, and I'll just say for loop. Okay? So when I run this, just like this, we can say that 0 is an int list, 1 is an int list, 2 is an int list, and so on and so forth. So that is a relatively simple way to go through a list. Now, there is still a danger that I can get into a situation where this becomes an infinite loop if I start to change this list as I am iterating through it. So let's say I do something really wild like int list dot append I. So if you remember from last time, lists have a method called append, and that is add whatever you put in these parentheses onto the end of the list. So you can imagine the situation here where it goes 0, it says, okay, well, append 0 to the end of this list. So then it will become comma 0. And then the next iteration, it'll add 1, and then 2, and then 3, and so on. So when I run this, now we have another infinite loop, and it just keeps running. And in fact, I have what is probably going to be considered a memory leak here, where I have an object in Python that is gradually filling up my computer's memory. Now, fortunately, this particular computer has a pretty decent amount of memory, but in many cases, you might fill up your memory. So you want to be a little bit careful about this. And of course, this would fill up eventually because it's an infinite loop and there's nothing that's going to tell it to stop. Now, this sort of for loop can be used to iterate through anything that Python understands as an iterable. Now, you'll notice that this is just the numbers 0 to 9. Well, fortunately, there is a shorthand way of getting to this. There's a function in Python known as range. So let's talk about the range function. So range essentially will give you an iterable. It's technically a generator. We don't need to get into that. But it will give you every item or every number in a range. So if I say range 10, this will give me every number from 0 to 9. Okay, it doesn't include that final number that it has. So here, oh, and that has an E on it. So if I say for I in range 10, and I'll just say print another F string here, and I'll give it I, and I'll say with range function. So when I run this, oops, I didn't change that. Sorry. Let's go back to our code here. We do not want to do this. Okay, let's try that again. Now we can see we have 0 to 9 with the range function. So this is relatively simple, I think, or hopefully. Sometimes it takes a little bit of practice to kind of get your head around this, just because it can be an odd way of thinking about things. But in many cases, we might want to iterate through every word in a text and do something with it. And so we can use these for loops as iterators to do that. A couple of extra things about the range function. We have a few ways of making this a little bit more specific. If I want to go from one number to another number, I can say from 3 to 11. If I add a comma here, if I have 2 arguments, this will give us a starting place and a stopping place. And if I run this, we can see that now we have 3, 4, 5, 6, 7, 8, 9. Right? So it started at 3 and ended at 11. So, and I can say with range function 3 to 11. Or I could make this even a little fancier, and I could say, let's do a range from 4 to 20. And if I give it a third number, this is the step that I want it to take. So this would go 4, 6, 8, 10, 12, 14, 16, 18, and then finish, right? And so this is 4 to 20 by 2. And when I run this, we can see 4, 6, 8, 10, 12, 14, 16, 18. So this is another relatively handy thing to know how to do. One final note here, we can count backwards in certain cases. If I want to go from 10 to 0, so this would be 10 to 1, essentially. And if I give it a negative number, it will count backwards. And so here we can see 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? This will be a very handy way of running code a specific number of times. Now, one thing to be aware of is that when we are in a for loop, whatever our variable is here, now do note that this I is a variable that I have named. So I could call this chum, and I could change this to chum, right? And this will behave exactly the same. As long as I'm consistent in how I'm using my variables, Python will not complain. But what you do need to know is that if I want to change this value inside this loop, it will only stay changed within the loop. And I'll show you what I mean. So if we go back up here to this while loop, you'll notice at the end of the while loop, I am adding 1 to I. And that is because we start with I equals 0, and then we change it within this loop to get essentially to the end of the loop. With a for loop, any way you change this I does not affect the next iteration of I. So let's say I say I plus or equals 20 here. So what's going to happen here is this is just going to first give me 10. It will add 20 to that, and then I'll have 30. In the next loop through, I is not going to be this plus 20. It's just going to be 9. So then it's going to be 9 plus 20 is 29. So essentially I'm counting backwards from 30 to 21, rather than having this affect the state of the program. And that's just something to kind of be aware of as you work with these things, because in some cases you might say, well, I actually want to jump forward in this loop to get to a different part of my item. How can I do that? Well, with for loops, it's not really something you're going to be able to do, but with while loops you can. So just a heads up, that will probably never be a huge consideration for you, but just be aware. So let's also keep in mind that these loops don't have to just be with numbers, right? We could say if I have, a letter list, and this is A, B, sorry, typing is a little awkward with my microphone right here, C, D, E, and that's good enough. I can iterate through every letter in this list. It will basically give me back every string in the list. So I can say for letter in letter list, print letter. And this will give me A, B, C, D, E, right? Now, it will give me these discrete units. So if I change this to 15, for example, it will give me A, B, 15, D, E. So the for function doesn't care what is inside this loop. It just goes through and gives me every single one. Now, I can also iterate through a string. So if I say, my string is chug-a-lug, and I say for letter in my string, I will print letter. And so this will just give me CHUGALUG. Now, again, note that I'm calling this letter because it is good practice to name your variable after the things that are going to be contained within that variable. I could call this airplane, for example. So for airplane in my string, print airplane. Again, Python doesn't care, but I as a programmer care because when somebody sees that code, they're going to wonder why in the world I called that variable airplane. Right? But functionally, it is exactly the same. What else? Okay. So that is a start to these sorts of loops. Now, you might remember from last time that you can actually nest code, right? So for example, let's say I'm just going to use my letter list here again, and I'll just copy, well, I don't need to copy it down because it exists right here. So I'm going to iterate through this letter list again. So note that I'm not changing this list at all in this block of code. And so I can reuse letter list later on in my code with no trouble at all. So what I can do is I could say for letter in letter list, and then inside of this loop, I can do other things. So maybe I'll want to say if letter equals D, then I can actually execute more code. So print found D, right? So essentially the logic here, and it doesn't like that for letter, oh, sorry, that should be two equal signs. So for if letter equals D, it will go ahead and print D. Yeah, Norman has a good question, and I will get to that here in a second. I actually wasn't sure I was going to talk about that, but we can talk about it. It's fine. But if I execute this, what we can see is that it prints found D, because what's happening is that we're going through each letter, and it's only doing something if letter equals D. And I could, to see this, I could say print letter here, so it'll print letter, and then it will print another thing if it says found D. And so now you can see A, B, 15, D, found D, E. Okay? There is a way of iterating through an object one item at a time while also returning the index of that item. So where does that item appear in the iterable object? And so in this particular case, let's say I'm talking about my string. So if I have for airplane in my string, what I can do, or let's change this back to letter, because that airplane is not good practice. So for letter in my string, print letter. This, of course, is exactly what we have up here. But if we want to see the index of the letter at the same time, what we can do is we can say I, and of course, we're naming this variable. So we could say index, we could say hello. It doesn't really matter. I'm going to call it I. And then instead of just iterating through my string by itself, we would use enumerate. And so what enumerate does is this is a function in Python that just goes through your object and gives you back both the contents of that object and the index of the item. And so now if I print I, comma letter, it will print 0C, 1H, 2U, 3G, 4A, 5L, 6U, and 6G. So that's relatively simple, and that is also something that is extremely useful. And I actually hadn't planned on talking about that, so thank you for bringing that up. There was one other thing I wanted to mention while talking about loops. We can, of course, put loops inside of loops inside of loops inside of loops. But that is often not how we're actually going to want to do any processing. If we can avoid nested loops, we're going to want to, because these are things that will take a long time to run. And I'll give you an example. I'll say for I in range 10 and for j in range 10. And I will print I, comma, j. And let's also say I'm going to add another counter variable before to keep track of how many total numbers of times this code executes. So I'm going to say total loops equals 0. And then each time I print, I'm going to add 1 to total loops. Total loops. Total loops plus or equal 1. And then I'm going to print total loops. And so what we'll see is, of course, 0 to 9, and inside of that 0 to 9, this is going to run 100 times, right? So when I run this, it's going to print, obviously, we start here, 0, 0, 0, 1, 0, 2, then 1, 0, 1, 1, and so on and so forth, all the way up to 9, 9. And then that ran a total of 100 times. And here I'll just say total loops, just so it's clear that this is what's going on. So if I add 1 to this and I run this, all of a sudden it doesn't just run 1 more time, it runs 10 more times. And so if instead I wanted to run this 100 times, of course, it's going to be 1,000. This gets compounded every time you add an internal loop. So if I say for k in range 10, this, of course, will run 1,000 times. And then every extra 1 is going to run an extra 100 times. And so here I'm not printing k, but 1,000 total loops. If I add 1 here, it should be 1,100 total loops. So you can see that loops, at small numbers are fine, and they will run relatively quickly, but sometimes you're going to want to avoid them. Okay? That's all on loops for the moment. We will be coming back to loops because we're going to be using them, to do a lot of analysis here. But I want now to move on and talk about interacting with our file system, okay? Because in many cases, all of the code we've been doing up to this point in this workshop has been stuff we've written in our files itself. But what if we want to load in text from elsewhere? So I'm going to start a new file, and I will call this filefun.py. And let's imagine I want to do something with one of these Sherlock Holmes stories, or the whole of Sherlock Holmes. Well, one way I could do that might be a little bit naive, is I could say, well, Sherlock text equals an empty string, and I could just go in here. Let's go to my desktop, and I go into English here. I go to the Adventures of Sherlock Holmes, and now this opens up in my file. I could just Control A to highlight everything. I can copy it. I can paste it in. And now, of course, it completely breaks because this kind of string doesn't go across multiple lines. If I save this, you can see how this would just simply not work in any meaningful sort of way. Something that I did not mention is there are strings in Python that do go across multiple lines, and they are formed with 3 single quotation marks. This is a multi-line string. I can use this to add lots of information about how this code works. So these are also handy, and if you see code made by developers, you're going to see a lot of these multi-line comments just because you can put a lot of information in them and you want to be documenting your code. So the question, of course, is, well, how do I do anything with this? So to start with, what I'll do is I'm just going to copy the Adventures of Sherlock Holmes, the file, into this directory that I've already set up for myself. So I have from 0 to n here. I'm just going to simply copy this text, this file, into this directory. So it's in the same directory as my code. You can find these files on the GitHub page, and I encourage you to, so you can follow along with this. You can just download it, unzip it, and then put it in the same directory that you're working with. So we're going to start just with this. So let's say I want to open this file and see what's inside of it. Actually, I tell you what, we'll get to that in a minute, but let's start by writing a file rather than reading a file. I looked at my notes and I realized I have already gotten ahead of myself, and so I'll apologize for that. So first I'll show you how to write a file, and then I'll show you how to read a file. So reading and writing files is important in Python. It will help us save the results of our scripts. This is a process that is known as serialization. Anyway, usually we refer to serialization as the process of saving some object, some data type onto our hard drive so it doesn't disappear when our code finishes running. I think with something this basic, we might not call it serialization, but regardless, I'm going to show you this. And here is where we need to be a little bit careful. So we're going to write to file. Be very careful, because this will overwrite a file if it already exists. Okay? So if you use Python to write a file and that file already exists, your computer will delete the old version and save the new version. So here's where I can't offer a warranty for all of this. You'll have to just be very careful to not accidentally delete things. Okay? So, but if it doesn't exist, it will create that file. So let's look at my folder here, where I have from 0 to n, and I just have these basic Python files and this Adventures of Sherlock Holmes file. So what I'm going to do is I am going to create a variable, and inside of that variable, I am going to put a file handle. Okay, so I'm going to say write file equals open, and this open function in Python is going to tell it, hey, go in and open a file. Okay, and I'm just going to call this new file. I'll say new file.txt. The next thing I tell it is, how do I want to open this file? W is what tells my computer, or what tells Python, that this is going to write. Okay, so W is write mode. And then I'm going to tell it encoding equals UTF-8. So this tells my computer, or tells Python, what kind of character encoding, I'm going to be using. Okay? Now, you have to specify this on a Windows computer. Macs and Linux machines are a little bit more forgiving about this, but it's good practice. This is, it will be compatible with all different computers within reason if you add encoding equals UTF-8. Anytime you have a parameter that has a variable name equals, this is specified by this open function, and this is an optional parameter. It's known as a keyword parameter that's going to tell Python, what our character encoding is in this particular case. So once I have that file, I can start writing things to it. I can say write file dot write hello. And then because we are good citizens, we are also going to close the things that we opened. And this is an important thing that you are going to need to do, because it's not just good practice. If you don't close the files you open and you have code that is going to iterate through hundreds or thousands or tens of thousands of files, if you don't close those files, they'll be open in your computer's memory and you might run out of memory. Okay, so always close the files that you open. So note again, my directory here has no file called newfile.txt. If I run this code, and I'll just clear this off, I'll say Python file fun. It runs, and note that it doesn't show me anything because I am not printing anything to screen. If I go back here from 0 to 1, all of a sudden you can see that I have a new file called newfile.txt. If I open this, you can see that it says hello. Now, to show you where this can get a little bit dangerous, let's imagine instead I want to say, this is really cool. So right now, before I run this code, this file says hello. If I run this instead, it's not going to give me a warning and say, hey, this file already exists. It's just going to immediately delete it and overwrite it. So if I run this again, and I come back over here, you can actually see that now it says this is really cool. Now, VS Code is nice in that it will refresh your file for you, but some other programs you might actually have to close out the file and reopen it to see the new contents. But please do be aware of that fact. Okay, so writing to file, important, but it can be a little bit dangerous. This process of opening and closing files is a little bit wordy, and it's something that we're going to do a whole lot. So Python actually has something that is going to be a convenience function for us that will close the file for us when we're done with it. Okay? And so this is something that is known as a context manager. So context manager will close the file when we are done with it. And you can use context managers for files. You can use them for processes if you're doing parallel computing. They're pretty handy for various types of functions. For us, though, we're mostly going to see them in the context of opening and closing files. So, and this is considered the Pythonic way of doing this. Okay, so Pythonic just means this is how Guido van Rossum wants people to do it. And Guido is the originator of the Python programming language. He's recently stepped down from the committee that still continues to guide it. But, you know, it is what it is. There are actually style recommendations that the Python powers that be make for us. And this is one of the things that they want us to do. And the way that this changes is I'll simply say with open, and then I'll still call it newfile.txt. I will still give it the write flag, and I'll say encoding equals UTF-8. And do note here that double or single parentheses or double or single quotes either are fine. They both work just as well here. So I'm going to say with this, and then I'll say as write file. Now, when I'm actually writing code, my head's not blocking the way. I'll often just shorten it to WF. And so in this particular case, this write file object, or this variable, is going to be functionally the same as this one. And so this is a code block, so this is indented. And then I will just say wf.write hello writing to file. And with it like this, as soon as I exit out of this code block, Python will just close the file for me. And so this is a really useful thing to be aware of, okay? Because this will make kind of memory management a little bit easier to deal with. We're already pretty lucky in Python where we don't really need to be paying much attention to memory usage of the things that we're doing. This is not like C where we need to call something like malloc to actually allocate the memory for our various objects. This is about as far as we're going to ever need to think about it before we get into things like multiprocessing. But that's another thing for another day. So functionally, this line of code, the same as this line of code. Of course, we're writing a different string to this file. So do note, if I run this, this actually opens that file twice and writes to it twice. But you'll note that it will not contain both of those pieces of information. If I open new file.txt, you can see it only has that second one. And that is because of how I am opening it with this W. Okay? Now, writing is, of course, useful, but often we want to read from a file. So this is going to be essentially exactly the same. I'm going to say with open, and in this case, I'm just going to open this new file right back up. I'll say new file.txt, but instead of W, I'll give it R. This is, of course, for reading the file. Encoding, again, UTF-8. UTF-8, and this is the Unicode standard. We might talk about this. I do talk about this when I teach my class because we get a little bit more into the why of things than I think we have time for here. But it's good to know. We could say as WF, but of course we're reading from this file, so I like to say as RF, and I can say text equals rf.read. Now, once I've done this, this text variable will contain hello writing to file. It will contain whatever string exists in the file when it reads it in. And so what I can do, I'm going to close that and this. Okay, so now that I have text here, I can go ahead, or I could call it contents. I could really do whatever. This .read function just says go in there and return to me the contents as a string. I can print text. And now we'll see that it says hello writing to file. But in this case, of course, we're actually reading to the file. But one thing to be aware of, and this is where Python is distinct from some other languages, is this text variable. Its scope is inside this context manager, but I can actually use it once I am done with this context manager. So once I have unindented my code here and I print text, this rf object is now completely inaccessible. It's gone. I've closed the file and moved on. So for example, if I print rf down here, well, actually, it still tells me the object, but it's no longer an open file. So I think if I tried to read from it, if I tried to call read here, I might eat my words. Yeah, no. It failed. It says IO operation on closed file. So that tells us that, in fact, this context manager did close this file. So that is handy, as I often want to say. The other flag that you might want to know about is, so often what we'll want to do as we're working with files is we don't want to completely overwrite it. We might want to add to it. And you can, in fact, do that with open new file. And instead of writing here, if I append to it with the A flag, and I'll keep my encoding the same, UTF-8, and here I'll just call this AF, and we're going to work this with this file AF. And if I say AF.write, adding more information, if I run this, we'll see now, if we go back to our new file, we can see that it now has adding more information in it. Now, of course, note that it just added it immediately after the previous contents here. So if we wanted this on a different line, we would have to tell Python to add a new line here. So we might do something like we could write a new line separately. We could say af.write write new line. And so this \n here represents a new line character. And if we rerun this and come back here, we can see that now they're on their own lines. Now you could also come back here. Instead of doing these separately, you could say /n here. That would work just as well. But often it's nice to keep them separate and distinct. And what else? Oh, one thing to know is that I can add multiple write statements here. And I can say this is more info. And this will just add. It won't completely erase because we're still using that same file object. So if I run this, you can see that it printed that here. We can say this is more info. It didn't overwrite it because it only overwrites the file when you first call that flag object. So be careful. You don't want to accidentally delete a file that is going to be useful for you in the process of doing your analysis. So if we were working with that Sherlock Holmes file and we call it with a W, it would just be gone, right? So careful. It might be wise to back up your hard drive before you do a lot of these things. I mean, you should be doing that anyway. But as long as you're careful, you shouldn't ever run into any issues. I've never accidentally deleted anything that is super critical. I have definitely deleted things that I didn't want to delete, but I've always been able to recover just because I have backups and I'm not writing to files that I know exist and I know are valuable. So keep that in mind. It's already been an hour. Ooh, okay. I had a lot I wanted to talk about today, but I want to go ahead and take a couple minute break. I'm going to grab myself a little bit more water, and then I'm going to come back and I'm going to talk about dictionaries, and then we're going to write a little script that does some super, super basic word counting and character counting. And we'll be back with that in 3 minutes. All right. Well, welcome back. Thanks for the indulgence there. Yeah, so that is all I wanted to talk about as far as files are concerned. And this process of reading in files is going to be fundamental to how we write our own text analysis scripts, because often what we'll want to do is we'll want to put a bunch of files that interest us academically into a folder together, and then we'll want to go through each one of those and load them into memory and manipulate them in some fashion or another. We'll get to that. Definitely looking at how much I wanted to talk about. Probably not today, but we will get to that probably tomorrow. Okay, so there's one last data type I want to talk about before we get into writing a script that actually does something. But again, as I said before, if you have any questions, please put them in the chat. I think I'm getting a little bit better about keeping my eye on that so I know if people are saying anything. So let's close this, or rather, obviously, I will close this. And I will create a new file that I'm going to call, dictionary fun.py, and I will close that and get started. So dictionaries are another important Python data type that let you store information using a key and a value pair. Okay? So essentially, it will let you index things not by number, that is, when does it get added to this object, but rather by some key that you introduce, okay? And this could be number, of course, but generally it's not. Like lists, dictionaries can store any kind of Python object. They can store other dictionaries, they can store lists, they can store integers. There is all sorts of things that we can do. So I'll show you how this works. So let's create an empty dictionary. To do this, there are two ways to go about it. I'm going to call this my dictionary, or just my dict, and this will equal curly brackets. Okay, remember, lists are defined with square brackets. Dictionaries are defined with curly brackets. Now, of course, I could also create a new dictionary with the dict function. Okay, in Python, dict is a reserved word, and it refers to this dictionary data type, and calling this will create a new dictionary object. This is a process that is known as instantiation. I haven't gotten too much into some of the technical terminology surrounding these things, but keep that in mind, right? Here's where my approach might differ from your Intro to CS class that you may have taken. I'm a little bit less precise in my terminology, which is perhaps not a great thing, but I'm here to get us to where we can do some analysis. So let's keep on keeping on. So let's imagine that I want to create a data object that keeps track of people's names. So create dictionary to keep track of ages. So let's say I have an ages dictionary, and it has these curly brackets. Now, to tell Python what goes in a dictionary is first you need a key, Paul, and then you need a colon, and this will be the value. And so I am 37. Anyway, that is immaterial for the content here. But let's say we have somebody named Padma who is 25, and Gorp who is 155. Okay, so the thing to remember here is the keys come before the colon, and the values come after the colon. Now, there are a few limits on what can function as a key in Python. And that limit is the key must be immutable. That is, it cannot be changed in memory. So strings are fine, integers are fine, lists are not fine. Okay, so I'll add this here. Keys must be immutable. They can't change. So for example, if I wanted to make this a list, Paul and Jerry, for example, this is not valid syntax because this list item can be changed in memory. If I wanted to do something like this, let's say, I was trying to keep track of business partners, this would need to be a different kind of data type. A tuple would work, but again, this is not what we're here to talk about. So I'm going to change this back to Paul. So if one thing to keep in mind is that, and this has changed in recent versions of Python, is that dictionaries do not remember the order of the items in the dictionary. Okay? Technically, they do in later versions of Python. I think in modern Python, it will actually remember the order things got added to a dictionary. But if you're working, I'm not sure when that changed, but it might have been like Python 3.5. If you're working with older versions of Python, every time you print a dictionary, the keys and the values are going to get jumbled up. Okay, so just do be aware of that. So I'm going to go ahead. So keep in mind that order is not preserved in older versions of Python. If I print ages, we'll see that in fact, clear that off, Python dictionary fun. And we can see that it just prints this dictionary that I have created. How do you create curly brackets on a Mac? They should be above your square brackets. Now, if you're on a European or a East Asian keyboard, it might be a little bit different. But on American keyboards, the curly bracket is on the same key as the square bracket. So it's just Shift square bracket. Hopefully, I used to use European keyboards, but it's been a while, and so I don't remember where it is. But hopefully that helps. Okay, so the next thing we might want to do is we might want to get information out of this dictionary. I'm going to comment this out because I don't need to print this dictionary every time. Getting information from a dictionary, the syntax is going to look very, very similar to how we got information out of strings and lists, except instead of using numbers, because those are indexed by number, we're going to get it with our keys. So for example, I might want to get out Gorp's age from this dictionary, and to do that, I use square brackets and the keyword. In this case, the key is Gorp, and that is not Gorp. There we go. And if I print this, Gorp age, we'll see that it will print 155. Just like that. Okay? We can add information into dictionaries just as simply, and this is the same way you might do it in a list, except remember that in a list, we're going to, well, forget what I said. That's going off base. Let's just say that we want to add information to, add info to the dictionary. I'm going to say ages, square brackets, blobble equals 20. And so keep in mind that in this original dictionary, blobble does not exist, but down here, I am creating it. So I'm saying, okay, let's create a key here and set it to 20. So if I print ages now, someday I won't do that, print ages, now we'll see that it has this new item, blobble, in it. Now, of course, if I instead say, ages, let's see, Paul equals 25, what this would do is this would go into this dictionary and change this number. Thanks for joining, Norman. Yeah, we'll be back tomorrow, and of course, this stream will be up on YouTube as well. Okay, so and this will change that value for Paul. I'll go ahead and print this. Print ages, and you can see that Paul gets changed to 25. And finally, one thing to keep in mind is if you try to access information from this dictionary that does not actually exist, it will give you a key error. So if I try to say ages, Shannon is not in this dictionary, it will give me a key error. It just says, hey, doesn't exist, and it breaks my code. Okay. One of the cool things about dictionaries is we can iterate through them. And keep in mind, you can't guarantee with a dictionary the order in which things, let's see, I'll just comment this out, gives a key error. We can use for loops to go through every item that is in a dictionary. So, for example, if I went to say for key in ages, print key, this will actually give me an error because Python doesn't intrinsically know how I want to iterate through this dictionary. Do I want the keys? Do I want the values? Do I want them both? What exactly is it that I am hoping to get from this? So if I want to iterate through the keys, iterate through keys, I'll just say ages.keys with parentheses. Now, of course, this could be as I said, this is a variable that I am defining. If I do this, it will give me all of the keys in my dictionary. So that's pretty simple. I can also iterate through values for key in, why don't I say for value in ages dot values, print value. And so, of course, now it prints the values. Of course, these are disassociated from the keys, and often if we have a dictionary, we don't want to lose track of these things. So one option would be, we could say print ages key. If we did that, essentially we're iterating through the keys and we're going into the dictionary and extracting the value that's associated with that key. So, if I print that, then we can see it's Paul 25, Padma 25, Gorp 155, Blobble 20. There is one other way to iterate through a dictionary, and that is iterate through dictionary. We can iterate through keys and values. And here we'll say for key, comma value in ages.items, print key value. Okay? And so these are various ways that we can iterate through these dictionaries once we have information stored in those dictionaries. So here we are. We are at a place where we know enough Python, and I don't expect you to recall all of this off the top of your head, but I want to walk through the process of creating a very basic script that'll just tell us what is the most common character in a file. Okay, we know enough here. Let's start putting this together, and this might be a good place to wrap up today. We'll see. We have 40 minutes left. I think we can get through this. And then next time we're getting to even more exciting stuff. But I hope people stick around for this. Okay, so I'm going to start getting things set up so it will reflect what it might look like in the context of real research. So let me organize my notes here and come over here. And I'm going to go back to my desktop. I'm going to minimize this stuff for a moment. And what I want to do is I want to create a folder that will contain the files that I'm interested in analyzing, right? Right now, we're just working with single files, and we're going to continue to do that, but I want to be a little bit more organized than I have been up to this point. Organization is not my strong suit, but we're going to give this the best shot we can. I have this folder called English, and one for Chinese and one for French. So I'm just going to move those over into this folder from 0 to n. This is a fast operation, shouldn't actually take any visible time, but whatever. Okay, so now I have, alongside all of the scripts that I am writing, these different folders that are going to contain the corpora that I want to work with. And so we're going to work with them one at a time, but we'll get more deep into them probably next time in how to work with multiple files at once. So what I'm going to do, is I am going to create a new folder, or a new file that I'm going to call countcharacters.py. And I'm just going to save it here. You'll notice in my save dialog that it's not showing all those Python files. That's just because it's only showing .txt files for whatever reason. So let's write a script that tells us the most common character in Adventures of Sherlock Holmes. Okay? So all I'm going to do is I'm simply going to say with open, because I want to use a context manager, and I want to go into the English folder, and then I'm going to tell it, okay, this is a folder. So on a Windows machine, I can use a backslash. Technically, I need to use 2 backslashes because I don't want to get into that. It will take a front slash or forward slash, so I'm going to use that. This is the same on Mac and Linux as well. So I'm going to open English, and the file is called Adventures of Sherlock Holmes.txt. And I'm going to double check that just to make sure that this is the case. It's actually all lowercase with underscores. So I'm just going to grab this file name here and copy it over here. Okay, sorry about that. English/Adventures of Sherlock Holmes.txt. I'm going to open this with the read flag, the encoding, VS Code likes to offer suggestions for what you might want to be doing, and sometimes it blocks the view a little bit when you're zoomed in so far. So I'm going to say UTF-8. I'm going to zoom out because my lines are getting a little bit longer here. Hopefully this is not too small, and you can't, I think you should be able to see this fairly well still as RF. One comment that doesn't need to be said, I guess, is that I have this little ruler set up visually on my plain text editor at 80 characters, just because kind of conventionally you want to keep your lines underneath 80 characters. In some cases it's weird because we'd have to do something like this. I'm not going to do that here. I'm just going to let things go beyond 80 characters. That's another one of those stylistic things that Python recommends but doesn't enforce in any meaningful way. Okay, so I'm going to say text equals rf.read. Okay? And I'll zoom in a little bit here. Well, I'll leave that so you can see the whole thing. Okay, so I have my text. This is the text of the Adventures of Sherlock Holmes. And I'm going to print text, and I'm just going to say, let's print from 10,000 to 11,000, just to make sure that it's opening properly before I try to write anything. So I'll clear off my screen here, and I'll say Python, what did I call it? Dear, I think I called it count characters. Python count characters. Okay, great. And so you can see it says, and for its numerous glass factories and paper mills. Ha, my boy, what do you make of that? You can see here that it is loading in a sequence or a section from the Adventures of Sherlock Holmes. So now I know that, okay, it's loading in this file, and now I can do something with it. So I'm going to delete this print statement because it's not actually necessary. So one of the really great things about programming is you can do the same task in many, many different ways. And I'm going to kind of walk through the process you might go through as you create a script that tells us what the most common character in this text is. And we're going to refine it. And so if you notice things that are suboptimal, don't worry, we will be fixing those. So the first thing I want some variable to hold the most common character. So I'm going to say most common character, and this is going to be a string. So I'm just going to make this an empty string. So just 2 quotation marks. And I should be conscientious here. Current most common character. Now, I want to keep track of how often that character occurs. How often character occurs, and I'll call this character freak equals 0. And now let's just go through each character and count how often it occurs. Okay? So again, many, many ways of achieving this, but a fairly naive way of doing that is simply iterating through each character in the text, seeing how often it occurs, seeing if it occurs more than the current most frequent character, and then saving if it does. Okay? So to do this, I'll say for char in text, I'm going to simply save the frequency. So let's get frequency. And I'll say freak equals text.count char. So this will count how often each character occurs. Then what I need to do is check if freak is greater than character frequency. Because remember, on line 11 here, we are saving how often the most common character is. So now what we'll do is we'll say if freak is greater than character frequency, then what we want to do is we want to remember what this frequency is. So I'm going to take character frequency and I'm going to set it to freak. That is the current character's frequency. And then I'm going to save the most common character as our current character, right? So when we start, this is an empty string and we've seen nothing. And let's say the first character in this text is a T. We'll count that up, and of course it will be more than 0. So anything more than 0 is greater than 0. We will save that number to character frequency, and then we will keep track of the character itself. Okay? And that's it. This is all we need to do to count the most frequent character. So then we want to finish up our for loop so we get through every character in the text, and then we can just print out our results. So here I'm going to say print, and then with an F string, the most common character is inside square curly brackets. We will print most common character, and then we'll say which occurs, and then inside curly brackets, character freak times. Okay? Of course, we could just print off most common character, comma, frequent character frequency, but sometimes it's nice to be a little more verbose. And so now, assuming I haven't made any typos, if I run this again, it'll take a second to run, and then it'll tell me what the most common character is. And this is actually telling us something that we can significantly optimize, because this should not be a process that takes particularly long. I think this text is, I'm actually not sure how long this text is. We can print it out to check, but you can see that already this is taking a while. We can readjust this so it runs almost instantaneously, but I want to see what it gives us. And maybe I'll just cut the text a little bit shorter so it doesn't take quite as long to run. Assuming I don't have a bug, which is of course always possible, but I don't see anything that should cause an infinite loop here. So one way to make sure something actually runs without necessarily getting the correct answer, I'm going to go ahead and cut that. Yeah, you can see that when you interrupt it, it's still operating. You can check what it's doing. It'll tell you. What I'm going to do is I'm just going to limit text to, say, the first 40,000 characters. Okay, so this is not very much of the text, but this will help me just make sure that it runs. So if I run this again, it really should not be taking this long. And of course, let me know if you have any questions. Okay. Actually, okay. So the most common character is blank, which occurs 98,428 times. Okay. So space occurs 98,428 times across the entire text. Note that, of course, we're counting across the entire text, but we're only checking the first 40,000 characters. So, okay, sure, that is in fact functional. It's working. But what I'm going to do is, let's see. Oh, on the 23rd line here, I just am, let me make this a little smaller so you can see all of it at the same time. So here we're just inserting the most common character and this many times. What I'm going to do is I'm going to shorten this up a little bit here in text. And I'm just going to say text equals text. Let's just use the first 10,000 characters because we don't want this to take too long to run. Now, what I will do is I'm going to go ahead and run this again. And there you can see it ran much more quickly. The most common character is a space. I mean, true, but that is not particularly enlightening. So we might want to say, let's ignore the space, right? So what I could do is I could say if character does not equal space, go ahead and run the rest of it. Now, one of the nice things about using VS Code is I can highlight all of these things and hit tab, and it will tab everything out. So that's a really handy shortcut. So now what it's going to tell me is that the most frequent character isn't space, but instead it is E, which occurs 965 times. This is, again, anybody who's familiar with English, probably relatively intuitive, but, you know, okay, cool, right? Let's add a few more refinements here. And I'm going to save this. Let's see. I'm going to go back here really quick, and I'm going to save this and then save as count characters 1, just so every state of this is going to go up on GitHub. Oops. I'll say if char does not equal space. And I will, I guess, save as 2. So the next refinement might be, well, what happens if the same character occurs, or rather multiple characters occur the same number of times? Now, we actually know, because of how English works, that's not going to be the case, but maybe if we have a shorter string, there might be some sort of coincidence that makes that true, where E happens as often as I. So what we could do is we can adjust this a bit, and we could say, well, instead of an empty string here, we can use a list. And so if we use a list instead, now we can make this slightly more refined, and we can say if the frequency of the character is greater than the last one, what we can do is we can go ahead and say most common character equals this inside of a list. And then we can further ask elif frequency equals char character frequency. Then we can say most common character dot append char. So what would happen in this particular case is essentially if this number is larger than whatever is in character frequency, it will save the current character as a list. But if it's equal to this, it'll append it to it. Hopefully that makes sense. And in this particular case, if we run this again, we'll see that it's just E inside of a list. Oops, that's the wrong one. Python count characters 2.py, or is it _2? Yeah. And here we can see that we have a list of a bunch of E's. In fact, we have a list of like 900 E's. So here's another place for a refinement. I'll save as 3 here. And now we might want to say, you know, if we've already seen this character, don't append it, right? So we can say if char not in most common character, then run this. Okay, so now what we're doing is we're saying, okay, and so I realize we're getting a little bit complex here. We're scaffolding on more and more complex logic onto this script. Okay, so now what we're doing is we're saying if the character is not in most common character, go ahead and add it, right? That way, instead of having 800 E's, let's make sure I save this here. If I run this, let's see, oops. Oh yeah, here, this is characters 3.py. And now we can see that it gives us the most common character is list E, which occurs 965 times. So that's simple enough. But there's a big problem with this, right? There is a lot of wasted effort here because really we don't need to be checking E 965 times. We actually only need to check E once, right? We only need to count each of these characters a single time. So let's go ahead and save as 4 and make that refinement. So here I'm going to say characters 4. We'll save that. And now we actually, if we make this refinement, we don't need this line here. So I'm going to delete that because we're only going to be looking at each character a single time. And so in order to do this, what I need to know is I need to know what are all of the unique characters in this text. There are, again, many, many ways to do this, but we're going to take advantage of a data type in Python that only allows unique values. And that data type is a set, okay? So what I'm going to do is I'm going to say unique characters equals set text. So what this does is, in fact, I think this will work. Yeah. So what this does is this goes into our string and grabs the unique characters because every item in a set can only exist a single time. And so what we can actually see is let's go ahead and print unique characters just so we can see what happens here. And I'm going to comment out this other print statement briefly. If I run characters 4, we can see here are all of the unique characters in this document. So there's apostrophes, X, T, S, N, D, E, and so on and so forth. So now this code, instead of running, in this particular case, for char in text, which will run however long text is, and in this case, it's 10,000 words, if instead of text, we iterate through unique characters, then it's going to run much, much more quickly. And so don't need to print this. Let's go ahead and print this instead. And so now note the two differences that I've added here. I have got this unique character object, and I am iterating through the unique character object. Now, sets, even though they are unique items, do note that sets don't have a clear order. They're technically a hash table, and so you will never know where in a set a specific item actually exists. So it's not like it has indices. One of the cool things about sets, though, is it has constant time lookups. So it doesn't matter how big your set is, you can immediately get information out of it. And that's a really cool thing you can take advantage of if you ever need to be thinking about optimizing scripts that are running for hours on end. That right there is a huge optimization instead of looking inside of a list. But again, I'm getting ahead of myself. And so let's run this again. And now we can see, okay, it got E, which occurs 965 times, and it did it seemingly quite quickly. But now let's see what happens if we get rid of this item on line 6. Remember before when I ran this, it took a long time? Look how fast that was. It found E occurring 54,627 times extremely quickly. Okay? And that's because I'm not running through every single character in the text and performing a count. And we can actually check, well, how many characters are in this text. And I can just do something like, I'm going to say print, I'll use an F string here. The length of this text is, and then inside curly brackets, len text. Okay? So we can actually run functions inside of these F strings. Now, we don't want to get too complex because it will complain as soon as we get, too fancy. But just so we can see, the length of this text is 581,882 characters. So the length of length of unique characters. So this will tell me how many unique characters there are. So here we can see that it is 581,882 characters long with 98 unique characters. So this little optimization meant that instead of this loop running almost 600,000 times, it runs 98 times. And you can actually see that makes a really big difference in the efficiency of our code. Now, in many, many cases, we're not actually going to need to make optimizations like this because Python is pretty quick, but it's always good to be thinking about how quickly these sorts of things run. Now, we have 17 minutes left. So why don't I adjust this just ever so slightly to, instead of counting characters, we count words, or rather approximations of words. Again, we're not going to get into legitimate tokenization until tomorrow, but we can do our really quick split on spaces just to see how this would work if we wanted it to work for words instead of characters. Okay? So what I will do here is I'm going to go ahead and I'm just going to save this as count words. Count words, save it like this. And now, now let's adjust this. Okay, so I'm going to go through and I'm going to change these variable names because I want it to be clear what all of this code is actually doing. So if I want to get words, I'm going to need to tokenize the text into words. And as I mentioned, I'm just going to use split rather than a fancier tokenizer. We will get to those tomorrow. And I'm going to create a variable called words, and this is going to equal set words. Now, I could simply, sorry, I'm getting ahead of myself. That's text.split space. Okay? So text.split space will create a list of all of the words in this document. And now I could simply take the words and give it here. Now all of this code can run without it being altered, and it should work just fine. And I'm going to run it just, so that's the wrong one, Python count words. And it might take a moment to run, but this should also work. Okay, so the most common character is... here's an interesting thing we'll need to deal with. But let's just fix this before we kind of get into that. So here what we want to do is we want to say, let's get the most common word. And then here we'll call this unique words. All I'm doing are changing variable names. And there is actually a handy way you can change all instances of variables in VS Code, but I often forget exactly how to do that. So I'm going to change this to unique words. And I'll call this word frequency. And then I'm going to say for word in unique word, if word. Here, I'll say word does not equal an empty string. And then I'm going to say, I'm going to adjust this to get frequency. I want to actually look inside that words, Control-Shift-L, thank you. I'm going to look inside the words and count word. Maybe I should have just completely retyped this because I can see how everybody might be getting quite lost right here. But let me finish this up and then we'll talk through it relatively quickly. So if we do Control-Shift-L, and let's see here, we're going to replace Control-Shift-L. There we go. Yeah, so the way you can do that is, let's say I want most common word. I'm going to grab this, copy it, and I'm going to highlight most common character. If you hit Control-Shift-L, you see it'll highlight all instances of that, and I'm going to paste it in there. That's actually really handy because it can be easy to lose track of where you're replacing it. In this particular case, I'm going to replace char with word, and I'll just go ahead and do that and change this. And we have 12 minutes left, so maybe I'll make sure this runs, and then we can talk about the changes I made. I think this should be good. Okay, so yeah, I'm going to run it really quickly and then we can see. And this will take slightly longer because there are many more unique words in this text than there were unique characters, which makes sense because there are more than 98 words in the English language. And there are faster ways to do this as well. Okay, here we can see that the occurs 4,555 times. The text has 98,429 words. 20,431 of them are unique. So that is, that's pretty handy to know. And so what we've done is we have just adjusted our character text, or our character script to run on words instead, right? The only difference actually lies in these two lines. We're creating a words list by splitting up the text along the spaces. And so I could, for example, print, let's just print 100 to 110. This will give us the words from word 100 to the word 110. And we can see Conan Doyle contents. And here we can see an issue, right? We can see, in fact, our split is not very sophisticated. You see all these /n's. These are technically new line characters. And so our little, funky tokenization schema is not really working very well for us because these should obviously be separate words. All these empty spaces are happening because there are spaces right next to each other in the text. So there are a few quick refinements we could make. Some of those require regular expressions, which we will touch on at least tomorrow. But others of them are really simple. So one thing we could do is we could make this text all lowercase, because in this particular case, we might not care that the is both with a lowercase t and a capital T. So in this particular case, spaces themselves will not be in this words list, because we're using the space to divide it up, which means that they just disappear. It's no longer in the list. But we could actually filter these out, and we're going to talk about filtering next time as well. And so if we wanted to get rid of what are known as stop words, there are easy ways of doing that. We can get rid of these empty strings. We can get rid of exclamation points. We can do all sorts of things that will facilitate this approach. But the last thing I want to do relatively quickly is to talk about how, let me see here. We have 9 minutes left. I'm trying to decide, do I want to get into this now? And perhaps I shouldn't. Perhaps I should wait till next time. Because, in many cases, we don't actually care about the most common word, because it's always going to be the in natural English. In Chinese, it's probably going to be de, or zhi if you work in classical Chinese, or le. It's going to be probably a modal particle of some sort. And apologies, my French is so bad these days that I'm not sure what it would be in French, but it's going to be a very predictable thing. Word frequency basically falls on what's known as a Zipf-ian distribution, which means the most common word is roughly twice as common as the second most common, which is roughly twice as common as the next one. And it kind of has this curve. In French. That makes sense. So often what we're more interested in is what are the kind of sort of uncommon words that occur a lot. So for example, in Sherlock Holmes, maybe we want to know how often does the word murder occur? And so what we'll start with tomorrow is we're going to adjust this script so it's not just looking at the most frequent character, but rather the most frequent word, but rather the frequency of all of the words. Because we can make a really simple refinement to just save this, and instead of kind of doing this fancy, save it if it's the most common, we can simply use a dictionary to associate the word with how often it occurs. And so we'll get into that next time. Don't want to kind of jump into a new topic immediately. We covered a lot of ground today, and I think we're going to be ready to do more cool stuff next time, and hopefully get you to a place by the end of the week where you'll be ready to embark on the wonderful world of at least pretty basic text analysis, and maybe get to a place where you can start thinking about doing more advanced text analysis. So I'll stick around for a few minutes if anybody has any questions. Otherwise, enjoy the rest of the day. It is beautiful here in Virginia where I'm at. It's the beginning of a new era, and I hope everybody has a good day. And I'll see you hopefully tomorrow or sometime in the future. So take care. And I'll stick around for a few minutes to answer any questions any of you might have. And I will also post this code to GitHub as soon as I go offline. Oh yes, the link to the GitHub repository. Let me grab that. I should put that in the description, but it's right there. My line 29 has an error for some reason. Can you paste what the error is? Attribute error. Do you see? Let me show my screen here. Do you have the parentheses? Because if you don't have the parentheses, that can cause issues. Yeah, I do have an email. It's, I suppose. Oh, I see. String has no attribute to append. So there is my email address, if that is useful. Yeah, so on line 13, you see how I have a list here? You probably have an empty string there. That would be my guess. Or the other issue might be on line 27. You need the square brackets around word. Yeah, my pleasure. Hopefully it is useful. Because, yeah, if on line 27 you don't have those square brackets, a word is just a string, and when you try to append to it, it's going to get thrown off. It's going to cause an error. Oh, great. I'm glad. So I'm using an Audio-Technica 2035, I think. I actually got it because I do these videos, and I've been doing them for a few years now. And I purchased it back in, I think, early January 2019 or 2020, and it was came in very useful for teaching during the pandemic. So, yeah, my pleasure. I really hope this is useful for folks. And again, you can also reach out to me at that email address if you have questions later after the workshop is over or anything like that. Yeah, so I think I'll call it there. And enjoy the rest of your day. I have meetings to head to soon, so I'm going to have to call it at this point. So take care and talk to everybody tomorrow.